Hello Algebra 1 students, this is lesson 28 and our objective is how do you solve equations with variables on both sides? And really answer to that question is very much like the multi-step equations that we've already been solving and you already know how to do. The only difference is that when you have variables on both sides, you kind of have to bring variables from one side to the other, kind of like we already have done with constants. So not a huge leap, but it is a little bit new. So let's see what we can do. This is like example 1. Notice we have some x's on the left and we have x's on the right. So we're going to get all of our x's together. Okay, not a good idea to do with relationships, but in equations, yes. So what I'm going to do is I'm going to subtract 3x from both sides. And then 8x minus 3x is going to give me 5x's. And then 3x's minus 3x's is going to be 0. And then I have a plus 20, so 0 plus 20 is simply 20. Now we're to a place that we already know about, so 5 times x, so opposite separation is going to be 5, dividing by 5. These become 1. So I'm going to have 1 times x, or simply x, is equal to 20 divided by 5. Which is 4. So the answer there is going to be x is equal to 4. Try another one of those that's a little bit more complicated. We have some parentheses here we need to distribute in. So on the left hand side, this 4 is going to multiply by the 2. So this 3x is going to stay the same. 3x plus the 4 times the 2 is going to give me 8. 4 times the negative 2x is going to give me minus 8x equals 3 times 5x is going to give me 15x. 3 times 1 is giving me plus 1. And then I still have that minus 15, but I wrote 16. Minus 15 there. Okay. Now let's combine like terms. I'm looking here on the left, and I've got a 3x and a negative 8x. On the right I have a 1 and a negative 15 I can combine. So combine those two on the left, 3x's minus 8x's is going to give me negative 5x's. And then I have that plus 8 up there, so I'm just going to bring that down, plus 8. That should equal to 15x. Then I have 1 minus 15 is going to give me negative 14. Okay, now let's see what we can do. We're going to bring all the x's to one side. We can kind of choose, doesn't matter either way. I think I'm going to add 5x. The only reason I chose to add 5x is because this x is positive. Whenever I add 5x's to it, it's going to make it a bigger positive number. Whereas if I had subtracted 15x, then I'd end up with a negative x. So either way you get the same answer. I'm just wanting to go with a more positive number here. So on the left I have 0 plus 8, which is simply 8. 15x plus 5x is going to give me 20x. And minus 14. I'm trying to get that x by itself, so I'm going to add 14. 8 plus 14 is going to give me 22 is equal to 20x. Dividing by 20 to get that x by itself, this becomes 1. I'm going to come over here so I have more room. So I'm going to have x is equal to 22 over 20. But that would reduce to 11 over 10. So I'm going to just say x is equal to 11 over 10. Or 1 and 1/10. So either one of those is fine. Alright, now, when we're solving equations with variables on both sides, there are some special cases. It doesn't happen too often, but it does happen. So we're just going to do one of each, and I'll kind of explain it as we get to that point. So as we start off, we don't necessarily know that it's a special case. We're just going to go ahead and try to solve it like we normally would. So let's do that. Multiply this 4 in, so this 2x. It's going to stay the same. 4 times x is 4x. 4 times 3 is 12, so plus 12. That's equal to 2 times 3x is going to give me 6x. 2 times 6 is going to give me 12. On the left hand side I have some terms that are the same. I have 2x's here and 4x's. Combining those gives me 6x's. On the right hand side I have the 6x plus 12. So let's get all my x's to one side, so I'm going to subtract 6x. And then on the right hand side here, I have 6x minus 6x, that gives me 0. And 0 plus 12 is going to give me 12. So on the right hand side I have 12. On the left hand side I have 6x minus 6x, which is 0. So I have 0 plus 12, which gives me 12. Now, we notice as you look at this, we just have 12 is equal to 12. So what we have is what we call an identity. An identity is an equation that always comes out to be true. I remember that because I end up with something that's always true. 12 is equal to 12. When is 12 not equal to 12? Well, that's a trick question because 12 always equals 12. And in fact, you could have even noticed it up here where we had 6x plus 12 is equal to 6x plus 12. When both sides were the same, then maybe we could have recognized it there and we could have stopped and said this is an identity. Right? It's going to be true for no matter what x you plug in there. So kind of your answer for one like this would be identity. And then you could say infinite number of solutions. Because any x you plug into this would make this true because it's an identity. No matter what you plug in, it's still going to be true. Okay? Now, let's try another special case that again we wouldn't know it's a special case except for I just told you it is. So just pretend like I didn't tell you and just go through solving like you would normally. So this 9x right here, 9x. Then I have this negative 5 that I'm going to multiply in here. So negative 5 times 2x is going to give me negative 10x. Negative 5 times 1 is going to give me minus 5. On the right hand side I have 2 times 3x, which gives me 6x's. And then I have 2 times negative 6, which gives me negative 12. And then I have this negative 7x that's hanging out up there. Let's combine like terms, and notice on the left hand side I have a 9x minus 10x, so I can combine those. On the right hand side I have a 6x minus 7x. I can combine those. So if I have 9x's and I take away 10x's, it's going to give me a negative x. I still have that minus 5 there. On the right hand side I have 6x minus 7x's, so it's going to give me minus x, or minus 1x, minus 12. I'm going to get all the x's to the same side, so I'm going to just add an x to both sides. On the left hand side I have negative x plus x, which goes to 0, minus 5, so I'll have negative 5 on the left is equal to, on the right hand side I have negative x plus x, so that goes to 0. 0 minus 12 is negative 12, so negative 12. Now, when is negative 5 equal to negative 12? Well, it's a trick question because negative 5 never equals negative 12. They're not the same. They're never true. This is not equal. So, an answer like this, you would say no solution. No solution. No matter what number you plug into these x's, it will never come out to be true. Okay, so you're going to have three different options. First option is you solve it and you get a number for an answer like x equals 7. Okay, that's what most of them are. Then you have a couple of different special cases. One of them is called an identity, where you end up with something that is always true, like 12 equals 12. And then some of them come out to not be true for any number. No matter what number you plug into here, it's not going to come out to be true. And this one we'd say is no solutions. Your homework for today is on page 167. You're doing all of them from lesson 28, all of them from lesson 27, and then 12 more of your choice. Good luck. I already know you're going to do awesome.